right? So after that administrative interruption, this is what we call groups. So you can see these are the columns, and I said there are 8. So this is first column, second column, third column, fourth column, fifth, sixth, seventh, eighth. Those are what you are branding the groups. So there is a total of 8 groups, and these are the rows: first row, second row, third row, and the fourth row. These rows are called periods. So I have period 1, period 2, period 3, and period 4. So we have group 1, group 2, group 3, group 4, up to group 8. Periods are written using integers. Groups are written using Roman numerals. So I want us to fill the first 20 elements in order. We are saying it's built depending on increasing atomic number. Therefore, the first element, they are going to fill my table in such a way that I'll still utilize this space to do some other assignment that will help us understand what we're going to look at. Don't draw a squeezed table. We shall use this table to almost discuss on what we want for today. So the first element is called hydrogen. After hydrogen, there is nothing in between here up to the last group, group 7, which is helium, written as He. Simplest periodic table. After that, of course, this is number 1 in the periodic table. This is number 2 in the periodic table. The number below shows its position in the periodic table, i.e., its atomic number, which is the number of protons. From helium, the next element is called lithium, number 3. After lithium, there is what we call beryllium. After beryllium, there is boron. After boron, there is carbon. After carbon, there is nitrogen. After nitrogen, there is oxygen. After oxygen, there is F, which is fluorine. And after that, there is an element called neon. Those are the first 20 elements, depending on their increasing atomic number. And we expect that all of your students know these first 20 elements from number 1 up to number 20. So those are the first 10. From there, we'll continue to look at the next 10. The next 10 start with natrium, which is sodium, Na. After sodium, there is magnesium. After magnesium, there is aluminium. After aluminium, there is called silicon. After silicon, there is what we call phosphorus, P. After phosphorus, there is nitrogen, which is N. And after nitrogen, there is the next element, which is called chlorine. And after chlorine, there is the 17th element, which is called argon, Ar. Those are 18. We are left with only 2. Therefore, the remaining 2 are kalium, potassium, which is K, and calcium. Those are the first 20 elements. Therefore, iron formation.
Excuse me, teacher.
Yes, please.
Excuse me, teacher.
Yes, please. Yes, what?
After phosphorus, you said it's not.
After phosphorus, P, there is nitrogen. Oh, sorry. This one is sulfur, not nitrogen. Sulfur, S. Thank you for that observation. After phosphorus, there is sulfur. Then chlorine and argon. There are many types of periodic tables. I'm giving the simplest to enable me advance my point home. So details of the periodic table can be discussed later. And so on. So these are the first 20 elements. Position in number 1, number 2, this is number 3, this is number 4, this is number 5, number 6, number 7, number 8, number 9, number 10. This is 11, this is 12, this is 13, this is 14, this is 15, this is 16, that is 17, this is 18, potassium is 19, and calcium is 20. That periodic table has been constructed on increasing atomic number for the first 20 elements. This is what I want you to capture. So is that okay for all of us? Is that okay?
Yes, teacher.
Right. So if so, to go for ion formation, these are what we call atoms. These are elements, yes. Lithium, valence. That one, you'll be, issues of valence will come in later. Issues of valence will be coming in later because I'll tell you how to determine the valence of an element from a periodic table. So issues of valence are coming. I want us first of all to capture this table first and be sure that we know the positions of the elements. Simplest periodic table. All right. Now, having captured these as the elements in the first 20 elements and their positions, I want you to push you into something else. Writing electronic structure or configuration. It will help us to know why group 1, why group 2, why period 1, why period 3, and to answer the issues of valence, and to help us to know how ions are going to be formed. So let's go into what we call electronic configuration that we have covered. I don't know whether everybody, because now it's a combination of more than 2-3 students from various places. I don't know whether everybody has covered what we call electronic configuration. You know electronic configuration? If not, then most likely before I go to now go back to electronic configurations of the first 20 elements. And we shall now see electronic configuration of the first 20 elements should help us to discuss what we are supposed to be discussing. Do you know electronic configuration? Some people have information about electronic configuration, others not have information about electronic configuration. Now, what is electronic configuration? Electronic configuration shows the number of electrons found in each energy level around the nucleus of an atom. Number of electrons in each energy level, which means if you are looking at an atom like this, if this is an atom has a nucleus. Around the nucleus are what we call energy levels, regions where electrons can be found. These energy levels range from 1 up to a total of about 4. That's why we are seeing, by the way, 4. 4 represents the number of energy levels that we have. 1, 2, 3, 4. So they'll be question to move on. Sure. So energy levels are regions around the nucleus where the possibility of getting electrons are very high. So there is one energy level. There are some atoms that have gotten 2 energy levels. Others have 3 energy levels. And at our level, the highest number of energy levels are how many? Are 4 at our level. So this is an energy level. The region next to the nucleus. So it has 1 energy level only. This one has 2 energy levels, 1 and 2. This one has 3, 1, 2, and 3. This one has 4. If this is the nucleus, this is 1, 2, 3, and 4. So those are what we call energy levels as a reminder. The region around the nucleus where you can find electrons. Now to give the electrons these energy levels, there is a rule that we follow. That the energy level number 1 can accommodate a maximum of 2 electrons only. Energy level number 1 can take a maximum of 2 electrons only. Others can take a maximum of 8. I repeat, in writing electronic configuration, the energy level number 1 can take a maximum of 2 electrons only. Other energy levels can take a maximum of 8. That's what we call the octet rule. Energy level number 1 can accommodate only 2 electrons maximum. Others can accommodate more than 2, but cannot exceed 8. Therefore, atomic number 1 has 1 electron only, which means if it has 1 electron, this element has only 1 energy level. And this one energy level has only 1 electron. Therefore, its electron configuration is 1. Electron configuration is a ratio that shows the number of electrons in each energy level. A ratio that shows the number of electrons in each energy level. But given these electrons has a rule. Energy level number 1, room number 1, house number 1 can take a maximum of 2 children only. Other rooms can take a maximum of 8. Remember that as a rule. So in this house, there is only 1 room and it has 1 student. Therefore, electron configuration is 1. Helium has 2 electrons. So what's the electron configuration? The electron configuration is 2. It has only 1 energy level, and this one energy level takes the 2 electrons. If this is hydrogen, now helium is that one with the 2 electrons, and they are finished. Already this information, if there are issues with periodic table, I'll forward the notes for you on WhatsApp so that you can handle these parts quite very well so that you can continue with the lesson the next time. So lithium has how many electrons? 3. So what's the rule telling us? The first one takes how many? 2. So how many electrons remain? 1. So it takes 2. How many electrons remain? 1. You push the next energy level. So the electron configuration of lithium is 2, a ratio, double dot, 1. Beryllium has 4 electrons. If it has 4 electrons, the first energy level takes 2. How many remain? 2. You push them to the next level. So it's a ratio. It is 2 to 2. 2 plus 1 is 3. 2 plus 2 is 4. Here I'm seeing 5 electrons, 5, atomic number 5. So what do you think is the electronic configuration? 2 to
3. 3.
Wonderful. First one takes 2. The next one takes what? 3.
2 to 3.
So 2 plus, yes, 2 plus 3 is going to give you 5. The next element, carbon, with position number 6, has 6 electrons. So the electron configuration is 2 to 4.
4.
Very good. Therefore, can you feel these remaining ones? Nitrogen, oxygen, and neon. You feel them quickly. Feel them quickly. Feel them quickly. 1 minute. Uh-huh. 1 minute is over. I'm calling for your responses almost. All right. So I'm expecting to see the following. Mark yourself. If you have written here 2 to 5, you are correct because 2 plus 5 is going to give you 7. So here it is 2 to 6. With 9, it is 2 to 7. With 10, it is 2 to 8. Those are the first 10 elements with their electronic configurations. Let's cross to 11, sodium. Remember, the first can take a maximum of 2, the next can take a maximum of 8. So what's the electronic configuration of sodium? The first one
2 to 8
2 to 8 to 1. 2 to 8 to 1.
2 to 8
Therefore,
to
followed
1.
by 8, 2 plus 8, 10,
Followed by 1.
So this is 1. So for magnesium, it is 2 to 8 to 2. 2 plus 8 plus 2 is 12. For aluminium, it is 2 to 8 to 3. Can you complete the remaining part of the table?
Okay.
So this is 2 to 8 to 4. Therefore, complete the remaining. In the work that I will send you, you'll go from merely writing and also draw diagrams, draw to show. So phosphorus 15, it is 2 to 8 to 5. Sulfur 2 to 8 to 6. Wonderful. Chlorine 2 to 8 to 7. To 7. And for argon
2 to 8 to 8 to 8.
8 to 8. That is good. I'm preparing you for this and the body. Potassium
2 to
is
8
going to
to
be
8
2
to
to
1.
8
to
1.
2 to 8 to 8 to 1.
8 to 1. Because this one, the first one takes 2 maximum, next can carry a maximum of 8. So the second carries 8 full. Another one carries 8 full. The balance 1 electron goes out. And for calcium, finally, it is 2 to 8 to 8 to 2. 2 to 8 to 8 to 2. That has been wonderful with you. There are so many other versions of writing electronic configuration. We can also write it as 2 to 8 to 3. Using those type of brackets is another version of writing electronic configuration. I may tolerate 2, 8, 3, but it's not a good version. And I may also accept 2.8.3, though it's not a very good version. So in most cases, we use double dots or use this type of commas in writing electronic configuration. That has been a wonderful thing. I hope you can translate this into diagrams. I hope you can translate this into diagrams. Let us choose one. For example, let's choose chlorine. I want a diagram to show the electron configuration, electron distribution. For example, I'm picking out on chlorine only. So let us see if I pick out chlorine using a diagram only. What do I expect? I expect the nucleus for chlorine. You have seen the first energy level has 2 electrons. Therefore, I expect the first one drawn like that with 2 electrons. The next energy level has 8, and therefore I draw the second energy level. And you have seen it has 8 electrons. We shall position them in the north, south, east, west direction. So this is 1, 2, 3, 4. They begin to pair 5, 6, 7, and 8. What does it mean to you that the electrons exist in pairs? They exist in pairs. So how many are left? 7. So I'll come to the next energy level outside. And therefore this energy level, for purposes of seeing, it is now, this is 1, 2, 3, 4. You now begin to pair them since they are still there. So I can now pair this one. I now pair this one. Those are how many total? 4. There are 5. And therefore, I pair this one. The 7 electrons are finished. And therefore, it is this one which is not paired. So the EC is 2 to 8 to 7 using a diagram. At a later stage, you will convert all of this into diagrams. I'll give you a sample of notes you download and see how you can fill them so that you can move on. So this is what it means when we have the simplest periodic table. Now, my question to all of you is that I want you to look at this periodic table. Look at the groups. Look at elements that belong to the same group. What is common with the elements in the same group? Look at period. What's common with all the elements in the same period? Interpret. As scientists, you look at something and get information from it. You observe and interpret. So let us begin with the groups. Let's look at groups. I'll give people, I'm giving you about, please can you mute? I'll give you about 1 minute. Look at the groups and predict something. 1 minute, I've given 1 minute for all of us to observe. Can you mute people? Right? If you have gotten the answer, Kalema, Bushra, can you mute your microphone? Bushra, mute your microphone. Good. Study. If you have gotten the concept, you put up your hand. I'm counting the number of hands. Those who have seen the concept. When you look at the group, study groups, elements in the same group. What are you seeing? I'm still giving chances to more people. If you have seen the concept, you put up your hand. Yes, I am seeing the hands are increasing. I'm waiting until I've seen 66 hands. As scientists, look at information and interpret, collect data. Very good. We are over. What have you said? What have you said?
In group 1, they have a valence of 1.
Don't talk about valence. I don't know about valence.
They have a remainder of 1.
Remainder of 1. What have you captured? Let me pick on one person. For example, you picked yourself. What do you say about the group of an element?
They have the same number of outermost electrons.
A group of an element, in a given group, the number of electrons, the outermost energy level is the same. You look at group 1, 1 electron outside, 1, 1, 1, 1. You look at group 2, 2, 2, 2 electrons outermost. Look at group 3, 3 electrons out. You look at group 4, 4 electrons out. Group 5, 5 electrons out. Group 6, have you seen the 6, 6? Group 7, have you seen 7, 7? If I wrote bromine, you'll also see 7. Group 8, in most cases, apart from this abnormal one, all of them have 8 electrons. That is a good observation. So what are you noting? That the group of an element is determined by the number of electrons, the outermost energy level. You note that one. You capture that one. Summarize it somewhere. From the periodic table, it is noted that 1. From the periodic table, yes, Perth, what do you want to say? Perth, your hand is up. Huda, your hand is up. Come again. Lisa, you write down something, NB, that from the periodic table, it is noted that, it is noted that, so, maybe I write down something here. NB, from the periodic table, it's noted that, from the periodic table, it is noted that 1, the group of an element, is determined by is determined by the number of electrons. Is determined by the number of electrons in the outermost energy level. In the outermost energy level. That is not number one. And you have all seen it. Lisa, your hand is still up. The group of come again.
Down, the number of electrons increases.
The number of electrons increases.
Yeah.
Come again, Lisa.
Like when the group is going down, like from hydrogen going up to potassium, the number of electrons in
That one is coming next.
increasing.
That is NB number 2. That is NB number 2. So that one, she's telling us, let's move on. So let's note NB number 2. You look at the period. Look at the period. What do you predict about the period? Look at elements in the same period. Look at elements period 1, hydrogen and helium. What do you see in common? Look at period 2. You look at all those elements. Yes, please.
They have the same number of energy shells.
We don't call them energy shells, we call them energy levels. Please don't use the word shell. The word shell is not acceptable. So number 2, I've noted that the period of an element, elements in the same period have the same number of energy levels. So we have noted that elements, very good, in the same period, let us note, elements in the same period, elements in the same period have same number of energy levels. Elements in the same period have the same number of energy levels. Good. Elements in the same period have the same number. Yes, Lukwago, what are you saying?
Sorry, I left my hand up.
Hey, okay, it is okay. Now, having noted number 2, yes, please.
Explain more about group 1.
Group 1 elements. Group 1 elements have 1 electron in the outermost energy level. Period 1, they have only 1 energy level only. Because 1 electron went into only 1 energy level. And it was not even enough. Maximum number of electrons in the inner energy level is supposed to be 2. So this one have 1 energy level, 1 energy level. If you look at the structure for hydrogen, the structure for hydrogen, if this is the nucleus, it has only 1 electron. When you go, there's 2 electrons, and the energy level is full. There's only 1 energy level, the first one. That's why I said elements in the same period have the same number of energy levels. So period 1 elements have 1 energy level. Period 2 elements have 2 energy levels. Period 3 have 3 energy levels. Period 4 have 4 energy levels. You get it? But this 4 energy levels such that in group 1, the first one is 2, followed by 8, followed by 8, and the last energy level has 1 electron, as you drew a diagram. So this is what you are capable of noting. All right, having said so, let us classify these elements because they are going to help me to answer 2 questions here that are lingering, balances, doing what, and so on. So I want us to say, I'm going to use my periodic table here, but for you, you can convert this into a sentence. Which elements have I mapped up? I've mapped up 1, 2, 3. 1, 2, 3 groups.
Metal.
1, 2, and 3 are called what? Metals. Those are metals. 1, 2, 3 are called metals. 1, 2, 3 are metals. Now, from 5 up to 6 up to 7, 5 up to 7, 5 to 7 are called non-metals. Now, this group 4 are given a special name. Group 4 are given a special name called metalloid or semi-metals. Semi-metals means between the metals and non-metals. They are in between. If they are human beings, they are hermaphrodites. Group 8 are given a special name, inert.
Gases.
Noble gases. Inert or noble gases. You have summarized the periodic table.
Now I'm talking about halogens.
That one is going to come in as a special thing also. So among the non-metals, the group 7 are given a special name, halogens. They are non-metals, but given a special name called halogens. So I want to summarize my periodic table. 1, 2, 3 are metals. 4 are metalloids, semi-metals. 5 up to 7 are non-metals. But group 7 among the non-metals gets a special name called halogens. Group 8 or group O are inert elements or rare gases. We shall note one more thing only. We are going to note one thing, and I'll jump to something else. Let us just note one more thing. NB. 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 In between group 2 and group 3, you can even ask how to do a new periodic table and you leave space in between. Between group 2 and 3. On some periodic tables, you'll see this. Between group 2 and 3, between group 2 and 3, metals are elements called
Transition elements.
It's called transition elements. Transition elements. Why are they called transition elements? Because they have colors. They have different colors. They are called transition elements because they have different colors. Because they are colored. These other elements, all of them are either colorless, either all of them, most of them gray, and most of them colorless gases. But this one have specific unique colors. For example, you talk about copper. You have seen copper girl. What's the color of copper? It is brown, golden brown. What's the color of gold? You know how it looks like. So they have specific colors. That's what I call transition element, which means if I'm to draw a new periodic table, I'm going to leave some space. These elements are actually found between these two. So if I'm to create a new periodic table, I'll have elements in between. And therefore, those elements are the ones which are called transition elements. They are between group 2 and group 3. So for them to occupy this position, and when you move across, about 10 of them, beginning from number 21 and so on. So there are 10 in the number. We shall not study that. So this one gives us the simplest periodic table. Don't look for a periodic table that's going to give you goosebumps and goose pimples and a headache. This is the simplest periodic table that you need to know, where we have metals now, non-metals, and so on. I don't even want to know the technical details of the types of metals. Sijui alkali earth metals, alkali metals, no, just metals. This information, we need it here. That's why I've started from here before I come here. Right? So I want us to mention something small called balance. And I'm not going to erase this periodic table. I'll still have it, but I'm going to remove a few things on it to give me what to look at. So I want to remove this work down here. We have captured it. I no longer need it. I still refer to my periodic table. So let me remove this NB. I no longer need it. And let's write the word balance. Balance. The word balance, the simplest definition I want to give you, the simplest definition is balance means the combining power of an element. Combining power of an element. What is this combining power of an element? What does it mean? I.e., it means the number of electrons that can be lost or gained. I.e., number of electrons that can be lost or gained by an element. Number of electrons that can be lost or gained is the combined power. And losing or gaining electrons means getting involved in chemical reactions. Number of electrons that can get involved. So, i.e., number of electrons that can be lost or gained, you can also say it is also number of electrons that get involved in reactions. Not all electrons and atoms get involved in reactions. Those ones that get involved in reactions are the ones we call valence electrons. So how many electrons will get involved in the chemical reactions gives you the combining power, gives you the valence. I have scenarios to use that may look funny, but it's a reality. You could be having, let's imagine, let's pick on one girl. Majority of the students I'm teaching here now, girls, with a few boys. So let us imagine a scenario of having a girl who has money on her. This girl has, for example, has 10,000 shillings. This girl has 10,000 shillings. Out of the 10,000 shillings, 80,000 shillings is kept in her bra. 80,000 is in her bra. And you know where the bra is. Now, 2,000 shillings are kept in the pocket. Total amount of money, 10,000. 80,000 in the bra, 2,000 in the pocket. And she wants to get to the shop and buy an item quickly, and the people are there in the public. She wants to buy something at least. She has 10,000 shillings on her, but 80,000 is in the bra, 2,000 in the pocket. Which of these monies, the 8,000 and 2,000, which of these money do you think this girl will spend? It is self-explanatory. Everybody is, You can mention without putting up the hands.
2,000.
2,000.
The one in the pocket.
The one in the pocket, wonderful. But she has more money on her. But not all this man is going to get involved in buying items. So how much can she spend? She can only spend how much money? 2,000 shillings, period. Despite the fact that she has 10, she cannot spend what? 2,000. Why? The 8,000, the place that she cannot easily pick it and use it. But it's her money, it's on her. So what does it mean? It means her balance is 2,000. Combining power. What she can easily purchase. What she can easily buy. She can only buy things worth 2,000 because of the position of the money. But she's not using it. She's only using 2,000 in the pocket. So the balance of this girl is 2,000. Number of elections that can be, she can lose 2,000. She can buy items worth 2,000. And that's the best. Once the 2,000 is done, she cannot begin to undress in public, look for the other money for her to undergo chemical reactions. I hope I have explained what balance is. Number of elections that can get involved in the chemical reaction. You can either give or you can accept. So having labor to define the balance using these two scenarios and the local example that I hope that we have all picked, let us now see how do you determine the balance. To determine the balance of one element, you look at the number of electrons in the outermost energy level. That's why I'm insisting on this periodic table. I can't do much without the periodic table. All right. Now, the following should be noted. We are saying number of electrons that can be lost or that can be gained. Number of electrons that can get involved in the chemical reactions. I want you to note that metals, now you see the words are coming back. Metals actually lose. Metals lose. You note metals lose electrons. That's why we saw what is a metal and what is not a metal here. Metals lose electrons. What happens to non-metals? The non-metals gain electrons. Non-metals gain electrons. Which electrons get lost? Electrons in the outermost what? Energy level. So metals lose electrons in the outermost energy level. They lose electrons in the outermost energy level. Now, do you see the purpose of groups? You link up the purpose of groups. Now, do you see how many electrons can be lost? So what will happen to group 1 metals? They lose 1 electron in the outermost energy level. What will they lose the 2 electrons in the outermost energy level? What happens to group 3? They lose 3 electrons in the outermost energy level. Combining the power, number of electrons lost, number of electrons involved. By losing, it means maybe you have given to a friend, say chemical reaction. I hope you have captured that. What about non-metals? They gain electrons. Where? Gain electrons into the outermost what? Energy level. Remember, the outermost energy level has limits into the outermost energy level. They gain electrons into the outermost energy level. Remember, the outermost energy level is supposed to carry how many? Maximum of how many? 8. So you can see how many you can gain to raise the number to 8. All right? So,
Yes.
are we following one another? Metals lose electrons to the outermost energy level.
Yes, teacher.
And we have said, if they lose electrons, all electrons are lost. Do you see why it is group 1, group 2, group 3? And what is losing electrons? Valence, combining power. Meaning that for metals to react, they can only involve the electrons in the outermost energy level. So group 1 involves 1 electron. Group 2 involves 2 electrons. Group 3 involves 3 electrons. That's what you're calling the valence. If they are to buy, that's the money they can give out, not more, not less. Non-metals gain electrons into the outermost energy level. So let's look at group 5. Let's look at group 5. What are group 5 elements? Nitrogen and phosphorus. Are we there? Now, if they are group 5, how many electrons can they gain? They can gain 3 because the maximum must be how many? 8. So this one can gain 3. What about group 7, 6? They can gain 2. Raise the number to 8. Group 7 can gain only 1. Raise the number to 8. What about group 4? They will gain a total of 4 to raise the number. Exactly. They gain 4 to raise the number to 8. Therefore, from my discussion with you, my question is, what do you think is the maximum valence? What's the maximum valence?
4.
What's the maximum valence? Maximum valence cannot valence out of electron that can be lost or gained. So what's the maximum valence? The maximum valence is 4. If you are to gain, you can gain 4. If you are to give, you can give a total of 4. Here, what you do, you can give a total of 1 up to 3. Number of electrons lost. Number of electrons gained. You can't gain beyond 4 into the outermost energy level. So this is what I was trying to drive you at. So we are going to note by saying, having seen what combining power is a valence. So we shall now write the group of an element and we write the valence. So group 1, 2, group 1, 2, 3, 4, 5, 6, up to 7, up to 8, down like that. Group 1, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. In that format. Let us write them in that format. Here, I'm writing here. This part here. With my periodic table not removed. So what is group 1 element? What are group 1 elements? 1 electron, the outermost energy level. What are they? Hydrogen, lithium, sodium, potassium. What are group 2 elements? 2 electrons in the outermost energy level. Beryllium, magnesium, calcium. What are group 7? 7 electrons in the outermost energy level. Group of the period from what we saw. Now, we say metals can lose electrons in the outermost energy level. So, number of electrons lost or gained. So, these ones, what did we agree? That these ones lose. So, these ones, metals, we said for them they what? they lose electrons. We say these ones are supposed to be gaining electrons. Are we there? What about group 7, 8? They do not lose or gain. They do not lose or gain. So if so, how many electrons can be lost? So electrons lost. This one can lose 1 electron. They can lose 2 electrons. They can lose 3 electrons. Maybe let me write it here. These ones can lose 1 electron, can lose 2 electrons, can lose 3 electrons. Are we there? Group 4 can either lose or gain 4. Group 5 can gain 3. Raise the number to 8. Group 6 can gain 2. Raise the number to 8. Group 7 can gain 1. Raise the number to 8.
8.
Group 0. All of these are electrons. And therefore, you can now tell me the valence. So group 1 valence is 1. Group 2 valence is 2. Group 3 valence is 3. Group 4 valence is 4. Group 5 valence is 3. It is not 5. Because they can gain 3 to raise the number to 8. And group 7, the valence is 6. Valence is 2. Group 7, the valence is 1. Group 8, the valence is
0.
Group 8 balance is 0. They don't gain. They don't what? Lose. Why don't they gain or lose? Why don't they gain or lose?
They are
full.
not
Because they don't have a stable
They are
configuration.
not-
They already
not
have
because
8 as its outermost energy level.
That's the correct reason, because they are full. That's why we call them noble. That's why they call them inert. They don't react. Can a dead body eat food?
No?
no teacher.
Can it laugh? Can it cry? So
No
you are
teacher.
either happy or you are annoyed. So the dead body is inert, doesn't care whether you do what, doesn't get involved in any chemical reaction at all. You are either satisfied or hungry. For it, you can't know whether it's satisfied. It is hungry, we don't know. You bring a food, it does not eat. You do what's just there like that. Why? The outermost energy level is fully filled with electrons. That's why it doesn't participate in the chemical reactions. Those ones will come in later at a higher level. I am looking at the first 20 elements. There is something I'm building. Unless you come to radicals. So if you want to combine so many things at a go, you get lost. That's why I say the chemistry is hard, because you want to combine so many things at once. Combining so many things at once, you get lost. That's when the chemistry becomes hard. That's when the chemistry becomes hard. Let's go step by step. At the right step, we shall add other balances. This is not the end. Now, if you have to add everything at once, were you taught all reproduction in physics and they finished it? You just taught a few things. There is a male and a female, full stop. But now you go into details. I don't want to go into details. There is a reason as why I don't want to go into details of certain things. Slowly by slowly, I reach where you are. So I am looking at the periodic table with the first simple 20 elements from the information that is given in the chapter. Why some have more than one value, shall we see later. So we have captured this. Number of electrons that can be lost or gained, because where are we going? And what is an ion? In the ions, we are going to lose and gain electrons. Now, we're not sure how it's going to lose it and it's going to lose it. No. The only thing you can expect is can gain 3. And that is it. So other issues, let's leave them at the right time. They will be introduced. All right. So we have about 15 minutes. These 15 minutes, we can do something about ions now. You can see, now I am just ready to look at ion formation. But I need this information first. So group 4, by the way, they don't get so much involved in the reaction because it's difficult for them to lose, even when to gain the electrons are very many. So what you do? Somebody who wants 4 bananas and the one who wants 1, whom can easily give the bananas? You give those ones who want a few bananas. Now this one wants 4 tracks. This one wants 4 crates of soda. Buying the 4 crates of soda is not easy, but you can buy 1 crate of soda. That's why those with the balance of 4 don't easily gain, don't easily give up. They don't easily react. We shall see those ones later. I hope that my students have captured me with my periodic table and the issue of balance. Number of electrons lost or gained. It is more than that, but as for now, we take it to be the definition of balance. I don't want to look at the balance as a combining power, because what do you mean by combining? We may not understand. As for now, what's the balance? Balance is the number of electrons that can be lost or gained. Having captured that one, we shall proceed. Later, as we come to senior 3, senior 2, third term work, I will introduce balance using another term, and I will bring in other elements and have those having more than one balance. All right. Now, there are 2 things that I want us to note. I'm still with my periodic table. I'm not going to erase it today. I think I can remove these top things. I want to use this part and this part.
Yes, teacher.
So let me remove this.
Okay.
Okay, that is okay. Now there are 2 things. There is ion formation. We can now write ion formation. Ion formation. Now, I want us first of all capture that atoms form ions. Atoms form ions. Who gives who? Ions give what? Atoms give ions. But there are cases where an ion also give what? An atom, depending on whether there is loss or gain. Atoms form ions. Using which method? By either, my work has come back, by either electron what? Loss or gain. Atoms form ions by either electron loss or electron gain. Combining power is coming back. How many can you lose? How much can you spend? Where is the money? In the bra? In the pajama? So atoms form ions by either electron loss or electron what? Gain. So what is an ion? So by definition, the word ion means a charged particle. A charged particle. A charged particle formed when what? When an atom does what? When an atom loses
or gains electrons.
Electrons. From my discussion with you, which electrons will also gain? Which money will be spent? The money in the pocket. So what do we note here? That the electrons also again must be electrons involving on electrons, the outermost energy level get what? Involved. So this one only involves outermost. I want to remove this part of the periodic table. So ions means charged particles formed when an atom loses or gains electrons. So we are noting that only electrons in the outermost energy level. Only electrons in the outermost energy level. Are involved. So only money where? In the pocket. Only money in the pocket is involved. Don't bring the money in the bra, money in the underpart, money where, nowhere. Only money in the pocket is involved. Hidden money, please, it's your money, don't bring it. And you either gain or lose the money. One of the two, you not double deal. Good. So let us push on. If this is going to happen, it therefore means that we shall come up with two ions. The atoms that will lose and the atoms that will what? That will gain. You don't do both of them. Not both of them. All right. So, today, I want to summarize the following. They really want to note that number one, metals lose and non-metals do what? Gain. So shall end with the types of ions. Types of ions. So I can now remove this periodic table because we know what it means now to be in a group, to be in a period. So types of ions. Number one, we have the first type. So we must know what this one is. So cations, what are they? They are positive ions. Formed among metals. We now know what metals are positive ions formed among metals by loss of electrons. In the outermost energy level. Positive ions formed among the metals by loss of electrons in the outermost energy level. So you already know group 1, how many can they lose? 1. Group 2, how many can they lose? 2. Group 3, 3. Valence. We stop. So one end by saying, we shall see what it means. So in summary, group 1, what happens? Lose 1 electron. And therefore lose 1 electron to form a positive ion with a single charge, to form a cation, to form a cation with a single positive single positive charge. A single positive charge. So you go back to the periodic table. Therefore, what are the examples here? Hydrogen, isn't it? Hydrogen, what are they? Lithium, what are they? Sodium, what are they? Potassium. If you remember those group 1 elements. And therefore, what you will do for me is you write the electronic configuration, the formula of the element, its electronic configuration, and therefore formula of the ion and its electronic configuration. So allow me erase this part to give you a guideline on the assignment that you are going to do, shall pick from. So for example, we had hydrogen in group 1. We had lithium, we had sodium, and we had potassium. Hydrogen was 2, 2, 8, 2, 1. This one was 2, 2, 8, 8. So having lost 1 electron, hydrogen having H plus, single positive charge. The electronic configuration now doesn't have an electron, it's 0.
We can't see.
The camera. The camera is new.
Teacher, we can't see the work.
Hey,
The camera
hey,
is low.
Okay, the camera has been sorted.
Thank you, teacher. Okay, teacher.
Camera has been sorted. Have you seen that one? Hydrogen electronic configuration 1. Number of electrons can lose is 1. What do we end up with? H plus, single positive charge. How many electrons are left? You get that one?
Yeah.
Now let's 2 to what? To 1. 1. And therefore, what do we end up the formula? Li with a single positive charge. What's the electronic configuration now? So what's the electronic configuration of ion? It is just 2 now. Because this one is lost. It is lost. It is gone. We don't have it. And finally, as for now, what is sodium? Sodium with 2, 8 to 1. So what will be the formula? Na plus. So what's the new electronic configuration? It is now
2 to 8.
wonderful. And lastly, potassium for today is 2, 8, 8, 1. So what's the formula now?
2 to 8.
K plus.
2 to 8
Formula.
to 8.
K plus.
K plus. K plus.
What it is K what? Hey, you are all gone silent. K what? K plus. So what's the EC now? 2
to 8
to 8 to 8.
So you see combining power, number of electrons lost or gain, this time lost, or outermost energy level electrons, group 1, group 2. I want you to use this example to look at group 2 and group 3 and complete. You cannot get lost. My man, tomorrow is not going to teach chemistry because yes. You see one electron the outermost energy level. These are concepts when you master them. You can see.
Period 4.
You see 3, 4. You can see. Physics teacher has challenged you. So complete for group 2, group 3, and we shall pick our story from there. It has been a nice lesson.
Thank you,
Please,
Thank you,
Corona
teacher,
is
for teaching
too
us.
much
May
technical.
God
Thank you,
bless
teacher.
you
Thank you,
abundantly.
teacher.
Bye.
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 Thank you,
Next
teacher.
lesson is at Bye.
The next lesson is at 11:30.
What time are we
We have
coming
an
back?
hour.
That's at
11:30.
At 11:30.
11:30.
But we have one.
Guys, the lesson is at 11.
The next lesson is at 11:30.
Yes, at 11:30. So you have
Yes, at
an hour of
11:30.
going online. If you haven't showered, go and shower.
Thank you.
Me, I didn't shower. I woke up late. I just came straight to that lesson.
But we are in year 9.
Too much information.
Yes, I'm still in my night. No, my friend. Bye, you guys.
Bye.
Come on.